Hello friends, the topic for today is PIC 18F Port B. PIC 18 family is based on 16-bit instruction architecture incorporating advanced RISC architecture. Depending on the device selected and the features enabled, there are up to 5 ports available, particularly in PIC 18F 4550 microcontroller. They are identified alphabetically with designation as Port A, Port B, Port C, etc. Some pins of I/O ports are multiplexed with an alternate function from the peripheral features on the device. In the last video on PIC 18, we have covered the Port A. In today's video, we will learn the Port B of PIC 18 family of microcontrollers. Let us start. Welcome to our channel Engineering and Technology for You. If you are not subscribed to our channel, kindly subscribe and press the bell icon so that you can get notifications about future videos. The topic for today is PIC 18 Port B. Let us start with the introduction. Now, depending on the device selected and features enabled, there are up to 5 ports available. So, the ports are designated as Port A, Port B, Port C, Port D, etc. Now, some of the pins of the ports are multiplexed with an alternate function from the peripheral features on the device. So, in general, when the peripheral is enabled, that pin may not be used as a general purpose I/O. It will serve the peripheral. The peripherals such as UART, MSSP, ADC, so they are available on the microcontroller. So the port pin will serve the peripherals. Then each port has 3 registers for its operation. First register is TRIS, that is data direction register. Now the logic level of the bits in this register determines the I/O function of an individual pin of a I/O port. Writing logic 0 to bit in TRIS sets up the corresponding pin of port as an output and logic 1 sets up the pin as input. Then the next register is port register that reads the levels of the pins of the device. Say it is a act as a latch or buffer. It enables the MCU to read from an input peripheral such as keyboard or write to an output peripheral such as LEDs. Then the next instruction is LAT instruction, a register. So this is an output latch similar to port B, similar to port. This is used when the port is intended to function as a bidirectional port. Then the data register is useful for read, modify, write operations on the value driven by the I/O pins. Now this is for port A. It will vary, so it will be LATB for port B. Then let us see the model of a generic I/O port. Here the generic I/O port, it has got this is the simplified diagram. You can see there are 3 latches or D type flip-flops: data latch, here IS latch, and this is the input latch, and this is the input buffer, and the IO pin is external and available to the user. This is the IO pin. So we can write to the particular latch when the write signal WR signal is active. Similarly, we can write to this TRIS latch when the WR signal is active. Then let us see the port B, TRISB and LATB registers. Port B is an 8-bit wide bidirectional port. The corresponding data direction register is TRISB. When we set these registers to 1, that will make pin as an input. So the bit or the pin will act as a input pin. Then when you clear this bit, the corresponding port B pin will act as an output. Then the data latch register LATB is also memory mapped. Read, modify, write operations on LATB register. Read and write the latched output values for port B. Now here there is a weak internal pull-up. There is available for port B pins, and a single control bit RBPU will control it. So by clearing the bit that is available in the INTCon 2 bit 7, so we can clear this RBPU bit and make the pull-ups available. So weak pull-up is automatically turned on when the port pin is configured as an output, and pull-ups are disabled on the power on reset. Then let us see the internal block diagram of port B. Again here you can see the three latches: data latch, TRIS latch, and this is the input latch, and this is the input buffer, and this is the IO pin which is external. Now the data bus. So the data bus is here. Data on the data bus is latched on the Q output, and it will be available to the IO pin only when this buffer is enabled. So this buffer will be enabled by the TRIS latch. So TRIS latch, when we write say 0 into the TRIS latch, then the Q is latched here, 0 is latched here, and it will enable this buffer. So the pin will be now the output pin, and it can output the data. And when we write 1 to this TRIS latch, so 1 will be here, and it will disable this buffer. Then the pin will not be able to output the data. Instead of that, we are able to read the data. So through the input buffer, it will be given to the input latch, and then we can read the port. So in this way it will work. So this is the RBPU pin which is active low. So when we clear it, then this will be enabled, and we get the weak pull-up registers. Then let us go to the Port B interrupt on change feature. Here 4 of the Port B pins RB4 to RB7 have an interrupt on change feature. So when they are configured as inputs, then only this feature is available. So any pin is configured as output, then it is excluded from the interrupt on change. This feature is not available. Then pins are compared with the old value latched on the last read of the port B, and mismatch output of the RB7 to RB4 are all together to generate the RB port change interrupt. So there is a mismatch in the output. So that means there is a change in the level of the pin. So that will say it will set the flag, that is RBIF, interrupt flag. So that is 0 bit of the INTCon register. Then interrupt on change can be used to wake the device from sleep. The user in the interrupt service routine can clear the interrupt in the following manner. We can clear the interrupt by any read or write of port, so that will end the mismatch condition. and clear the interrupt flag. Then wait for 1 TCY delay. That is when we execute the NOP instruction, and that time it will. Then clear the flag bit. That's all. RB2 and RB3, they are multiplexed with the USB peripheral and serve as differential signal outputs for the external USB transceiver. Then RB4 is multiplex with CCSP, that is chip select function for the streaming parallel port. Now let us see the Port B IO summary. Now here the pin RB0, it has multiple functions, RB0, then INT0, SDI, SDA, and so on. So when it is used as an input output pin, so if it is 0, TRS setting is 0, it will be used as output. If it is 1, then it will be used as input. So Port B data input weak pull up when RBPU bit is cleared. Then INT0, that is, it will be used as external interrupt 0 input. Then RB1, it will be used as output or input. Then INT1, that is external interrupt 1 input. Then apart from that, it will be used for the SPI clock and I2C clock in the MSSP module. Then the next pin, that is RB2, it will be used as output and input when TRS setting is 1. Then it will be used as external interrupt 2 input, so INT2. So these are the 3 interrupts, external interrupts. Then the next pin is RB3. It is used as output or input, and then for the TCP2 compare and PWM output, and also used as an external USB transceiver VPO data output. Then next we have the RB4, that is used as the output when it is 0 and input when it is 1. And similarly it is used as interrupt on pin change. So KBI 0. Then RB5, it is used as output input, and then KBI 1, that is interrupt on pin change. And apart from that, PGM, that is single supply programming mode entry. Then RB6, it is used for input, say input output, and KBI2, that is interrupt on change, and PGC, that is serial execution, clock input for ICSP and ICD operation. Then RB7, when it is TRS setting is 0, it will be used as output, 1 it will be used as input, and it is also used for the interrupt on pin change. So RB4 to RB7 all are used for interrupt on pin change, and the RB7 is also used for the PGD, that is serial execution data output and serial execution data input. So these are the functions of Port B. Then with this we come to the end of this video. If you have any queries, you can contact me on Facebook, Twitter, Gmail or Instagram. Then if you like the video, press the like button, share with your friends, and subscribe to our channel Engineering and Technology for You. And don't forget to press the bell icon if you want to get notifications about future videos.